Welcome to Hands-on AI, where we walk you through AI lab step by step. I'm Annie.
And I'm Ayo.
And today, you're going to learn how to deploy Gemma 4 model with Ollama or vLLM to Cloud Run. And essentially, you can connect your agentic system to Gemma 4. But before we dive into this architecture on the screen, let's take a step back to understanding this end-to-end agent system management. So Ayo, why don't you start to explain the cost and capacity?
As you mentioned, so throughout this lab, we're going to be learning the pillars of end-to-end agent system management. There's a lot of different considerations that go into that. There's cost and capacity considerations. So how do you optimize your resources, such as GPUs, when you're deploying self-hosted models? Model strategy, when do you select open versus closed models for your use cases? Serving at scale, how do you optimize for multi-throughput and serving multiple users at a time? Security and safety is another one, as well as observability. So these are all the pillars we're going to be covering as part of this lab.
Yeah. So before we go through how to deploy Gemma 4, we need to understanding this difference between closed model and open model. Closed model like Gemini, it's great. It's like it's state of art. It's fully managed, easy to start. An open model like Gemma, it's easy to take control. You can even fine tune it. So why we are talking about Gemma 4 today? Why would you want to use an open model, Ayo?
Yeah, it's a great. You just talked about a lot of the pros of using open models. A lot of industries, such as healthcare or finance, they're working in industries where you may not be able to pass data over the internet, or you may be limited with how you can kind of handle your data. In those use cases, if you have to kind of call these models on premise or in kind of isolated scenarios, running self-hosted models is a really good solution for that.
Yeah.
As you mentioned, you can customize the model. So a lot of use cases have very domain-specific data where you can kind of improve performance by tuning, and you can do that with an open model. As opposed to closed models like Gemini, essentially, they're great out of the box, they're state-of-the-art, and they're really general, but you may not be able to customize it as much beyond tuning, beyond prompting and system instructions of that nature. So those are the benefits of using open models.
Yeah, and also cost is also another consideration. You can take a look at this diagram that the more you use, if you're using a closed model like Gemini, the cost is increased per API call, versus if you're using open model like Gemma, the cost is not linear growth, right? Because it's based on the infra.
Yeah.
So coming back to this model strategy,
yeah, there's many dimensions to consider. We talked about a few of them, but those are just the ones to keep in mind. But beyond that, it's also important to know that the reason why we're so focused on model strategy is, at the end of the day, these models act as the brain behind your agents. So when you're using something like Google's Agent Development Kit, not only could you use Gemini as the brain behind these agents, you can use open models as well. So that's something that people sometimes they don't know. They think you can only use Gemini, but in reality, you could pretty much use any model that you want, because Google ADK comes with a light LLM wrapper that allows you to kind of connect models as you see fit. Later on in this lab, we're going to learn how can you use Gemma 4 as the brain behind an agent.
So essentially, agent is that you're using the model as a brain, and then to reasoning to pick which tool you want to pick to make a decision. And as you can see on this diagram, with the agent architecture, so the model you're choosing really can determine the upper bound, the capability of your agentic system. That's why it's very important, and you want to be smart to choose your model. And when you choose a model, you can think about the performance of the model, the use case you want, and also the cost. You have different angle to pick your model smartly. And so this is the overall architecture we're going to dive into today. As you can see that on this right-hand side, we're going to start with this runtime. So today, we will deploy Gemma 4 model with service vLLM and Ollama. But yeah, why we have this two different way? What is the real difference between Ollama and vLLM?
Yeah, they're both LLM serving frameworks, but you tend to see Ollama used more in development use cases. It's really easy to install and get up and running. So it's great for experimental POCs. And you can also use it for multi-GPU support use cases. vLLM is great for production use cases. It comes with page attention. It's great for memory efficiency, and allows you to kind of do multiple concurrency when it comes to calls and dynamic batching. So again, Ollama is great when it comes to development. vLLM is great for production. And there's other LLM serving frameworks as well, like TensorRT, LLM, and such. So there's a lot of options to choose from in the world. But for this lab, we're focusing on Ollama and vLLM.
And don't forget, you can also deploy a model to what has AI through Model Garden. That's also another choice. It's a managed service for you. Yeah, so Ollama is very easy to install, and it's very good for you to try things in your local development. And let's get started with Ollama. So this is as you can see from this diagram, what we want to do is we want to first pull the model from Ollama, and then we want to build this image with Docker. So once we have this image, we're going to send it to the artifact registry, which is a container on cloud. And you can essentially deploy the image so that you can have this image hosted on Cloud Run. So that's essentially how your agentic system agent going to use connect to your deployed Gemma 4. And if you're interested, let's start by going through this lab. So we will have this link on the screen about what is this lab link about. But as usual, like IO, usually we want to start to do the equipment check with the credit, but today we're gonna skip the credit part.
Yes. Right? Yeah, today we're skipping the credits because this lab does require GPU, such as when we're deploying to Cloud Run, we will be equipping our Cloud Run instances with L4, accelerators and such. Because of that, we won't be giving credits for this lab, but please feel free to follow along. You could use your own credit accounts if you have them, or you can kind of sign up for free trial credits on Google Cloud Platform if you're a first-time signer-upper. Yeah, please feel free to follow along.
As always, we want to start our development in Cloud Shell on Google Cloud. To open that, making sure you go to console.cloud.google.com, and on the top right, there's a button. It's saying the Activate Cloud Shell. Just click that, and you will see this VS is similar to our VS Code, but it's on cloud. Essentially, it's a VM that hosting it. Yeah. Anything to add?
Yeah, as you mentioned, so the Cloud Shell editor is essentially like a VS Code on cloud. It's persistent over time, so any code that you develop or files that you create, you can come back to it a day, a week later. So please feel free to use it as your development environment, and that's exactly what we're going to be doing for today's lab.
Yeah, but one thing you need to notice is you will time out every 30 minutes or so for security reasons. So if you see any error for like IP, like address missing or some weird issue, or you ask you to re-authenticate it, just making sure to refresh the page to refresh your token so that it will keep you authenticated. And to get started, let's just set up our environment so that we are ready to deploy and host our Gemma 4 model. And as always, let's just copy this G-cloud auth. I'm going to zoom in. I'm going to copy this and then paste it to my terminal. So you can see this is a terminal. I'm going to paste it. So that making sure this Gmail account is the same account you have your billing account connected. And next, we need to clone this to repo. We'll clone those two repo, and one is the Agentverse Dungeon, another one is the Agentverse DevOps SRE. Yeah, maybe would you mind explain to our audience in case they haven't watched our previous episodes, they don't know about the Agentverse concept?
Yeah, so we're cloning two different repos. The first one, Agentverse DevOps SSRE, that one has all the template files for like the agent we're going to be deploying later on, the Cloud YAML scripts that we're going to be using for deploying our images to artifact registry and such. So essentially it has a bunch of staging and template files that kind of gets us up and running a lot quicker. The Dungeon repo has essentially the boss dungeon and files that we're going to be using for the boss fight later on in the lab. So once we build our agent, essentially we're going to be building up to a boss fight where our agent is fighting with another agent in the cloud via A2A. So that one just has files so we can kind of get that up and running. So by the time we get to that point, our boss fight is ready to go.
Yeah. Let's come back to this setup page. And next, you need to initialize a new project so that you have a Google Cloud project ready. And you can see that you always start with Agentverse Garden. You may have a different number here. Essentially, the script is creating a Google Cloud project for you. And it's trying to link the billing to this project. So you can see now how this full setup complete. But for if you're running the script, you probably notice that you have this, when you fetch the building account, it has a fetch failure. That because it's looking for a child account. So what you can do is, if you happen to have a building account with your credit card linked to it, this is what you can do manually in Google Cloud Console. Okay, now you're at console.cloud.google.com, and then in the search bar, so I just click this search icon in the search bar. I will search resources. So when I type resources, I have something called manage resources. So when I open the manage resources, this is where you can manage all your project and its corresponding building account. So you can select this Agentverse Guardian project, and here you can just click this button action and go to the building. So now this one, it's already attached to my account. For your case, you probably see a pop-up window to see manage building, and then you can select the building that has your payment information linked to it. Next is, as always, we want to G-Cloud config set project. Why we need to config the project?
Yeah, we're just making sure that our project is set in the G-Cloud environment. So there's two ways you can kind of double check. If you're in the Cloud Shell, you want to make sure that you see your project ID in yellow. And beyond that, you also want to make sure that, again, the G-Cloud is set to the right project. So what we just did was making sure that the G-Cloud is set to the right project, which should match your Agentverse Guardian / some unique ID. Yeah.
Yeah. And next, we need to enable some Google Cloud API. As you can see, that those are if you take a look at the API we want to enable, it's including the storage, API platform. Basic storage is essentially you want to store your, later on when we do vLLM, we want to store our model in Google Cloud Storage. And when we want to deploy to Cloud Run, we want to enable Cloud Build. And we also want to have an artifact registry to store our image. So we want to enable this. And yeah, essentially we want to store our API key. So you want to enable a secret manager. Yeah, anything you want to mention, Ayo?
Yeah, so the only thing I would add is that just by enabling these APIs does not mean you're going to be charged immediately for these APIs. Essentially, you're just enabling them to be used in the project. A lot of people ask, if I enable AI platform and Google APIs, for example, will I start being charged by the second? No, you won't. You're only going to be charged when you actually use the API. So that's just one thing to keep in mind.
Yeah. And it's coming back to this. Yeah, so now we successfully finish enabling. And next is we need to create this artifact repository so that later on we can deploy our image to it. So coming back to this diagram, that we want to build the image, like we want to first pull the model from Ollama and build the image, and later on deploy this to image repository. Yeah, do you know why we want to have this design? Like, is there any other way we can do?
No, this is just best practice when it comes to CI in context of Google Cloud, where essentially you're building an image, you're storing it in artifact registry, you're deploying it to Cloud Run, and it's essentially, this is the build process that we're going to be enabling with Cloud Build. That allows us to kind of programmatically specify each of these steps, and then we can go ahead and just execute that Cloud Build YAML file. So you can see that later on once we get to that step.
Yeah, and also you can see that the model, essentially we directly build it because we do not have to store a model anywhere because it's baked in Ollama. You will see it really soon in our lab.
Yeah.
And yeah, so now we have this repo, like artifact repository created. And next one is set up the permission. I do know what is service account. Why we need to grant this role to the service account?
Yeah, great question. So every Google Cloud project has a default service account, and that's essentially going to be like the operator behind many of your default actions. So if we're uploading files to cloud storage or executing a cloud build deployment, you want to make sure that the default service account has certain permissions. So that's pretty much all we're doing here. We're making sure that the default service account has the ability to interact with cloud storage, has the ability to initiate cloud build jobs, has the ability to write logs and read the logs, has the ability to interact with Secret Manager, which we're going to be using later on for storing our Hugging Face. secret manager key. So as Annie just mentioned, for Ollama, we're going to be baking in the model directly into the container image. But when we actually use vLLM, we're going to be doing a different approach. We're going to be storing the model weights directly in cloud storage and pulling those model weights from Hugging Face. So there's different approaches that are kind of being enabled through this IAM permissioning.
Yeah, one metaphor I can think of is you can think of service account like a robot account.
Yeah.
Of yourself, and then you have different robot controlling different permission, and so that you can manage the project permission. And here we're using the same account for easy demo. But in production, you can have different robot account, like different service account for different permission configuration. And the last step is to warm up. Is we need to run this warm-up.sh script. So essentially, we want to using GCS views for our vLLM deployment. We want to run this warm-up script here to warm up our GCS views cache. And if you want to know what is GCS views and why we want to use that, stay tuned. We will talk about it in vLLM deployment.
Yes. Yeah.
Now it's finished. Let's host our Gemma for Ollama. Let's get started. All right, so let's get started. So first, we want to pull the image from Ollama. As I mentioned earlier, Ollama is great for local development and it's great for quickly testing any model because Gemma 4 is baked in Ollama, and you can see it's very easy. Like first, we want to create this Docker file, build the image, and with only this line of the code, you just need to run Ollama and pull this Gemma 4 from Ollama. So now you can just have this model from Ollama. So it's very straightforward. And just copy this and coming back to my terminal and paste it. So now we just create a Docker file folder. And what's next is we want to create this CloudBuild YAML file. So maybe you can explain what is CloudBuild YAML file before we explain what are inside the CloudBuild YAML file.
Yeah. So as mentioned before, CloudBuild is essentially the engine for CI/CD on Google Cloud. So essentially, it allows you to programmatically specify steps you want to run as part of a process. So pretty much all we're doing here is we just created the Docker file that defines our container image. Now we're going to build the container image in step 1. We're going to push the container image to artifact registry in step 2, and then we're going to deploy that container image to Cloud Run in step number 3. So that's all we're specifying here in the CloudBuild YAML file. Yeah, so basically it's like a blueprint file to specify all the steps you need to do, and exactly we're showing on this diagram. So we just did is we just we have this Docker file to explain how to pull this image. So you want to build this image and then push to artifact registry and deploy the image. It's like a blueprint file to including all this process we want to have over here. And let's just copy this and coming back to our terminal and paste it. But why we want to set the CPU to be 4 and why we want to be a concurrency to be 4, for auto setting, anything we need to be aware when we're trying to deploy our image to Cloud Run. Yeah, Cloud Run is a really powerful serverless platform. It gives us a lot of configuration capability. Yeah, so as you see here, we're specifying 4 CPU minimum for each machine of the service. We're specifying memory to be at least 16 gigabytes, which is really important. If we're going to be storing Ollama or Gemma 4 model on the image, you have to have a lot of memory capacity. So we're working with a 2B version of Gemma 4. So 16 gigabytes is sufficient memory for that. So that's why we're specifying that. We're specifying that we want to use the NVIDIA L4 GPU type. We're specifying concurrency to 4. We want to allow up to 4 parallel calls against the service. And yeah, so again, Cloud Run gives us a lot of configuration capabilities, and we're just trying to optimize for how we're going to be using it in the lab. As you can see at the bottom, we have min instances equals 1, max instances equal to 1. That's not going to be too common in production. You want to be able to scale beyond 1 machine. But for cost purposes, just so you're not kind of allocating more GPUs than you need, we're kind of just minimizing to 1 machine per service for this lab.
Yeah, also we have this allow unauthenticated for this lab purpose, but you can make it authenticated for security reason for your actual image deployment. All right, so next one is so now we configure this cloud build YAML file. So next step is actually, follow this blueprint in the cloud build YAML file and then finish this process with cloud build. So just copy this. Basically, you put this cloud build YAML file in the config file and then do the setting with the region and the repo name and project ID you have. And let's just go ahead and go to our terminal and go ahead to deploy the whole process. If you want to track the process of it, we can also go to Google Cloud Console in the cloud build to see the process. So now you can see that we just finished the environment setup, and now we're waiting for the build to complete. It's like trying to pull in the interval. So it's basically following the process, like trying to first build the image with Docker.
Yeah, and keep in mind, this cloud build process will take some time. So this step may take anywhere from 15 to 20 minutes, depending on how long things take. So feel free to take a coffee break and grab some coffee. But we'll be back once our cloud build job completes.
Yeah, it finished finally. And as you can see that we can go to Google Cloud Console to also see the process. Like you can search cloud build, we can see the process we just had earlier. And yeah, this is a building process we just having, because we have two building process. One is for Dungeon, another one is for this deployment. You can also see this image is registry deployed to Cloud Run. So let's just go to Cloud Run, making sure on the top left, it's selecting the project and go to the Gemma Ollama Big Service. And here we go. We have this. And we have this URL that later on we can connect to our agent. Okay, so now you have this URL, right? We have this URL, and we want to verify this is working by sending it the post request. So here, basically, what you want to do is this step, this Ollama URL, this step is to try to grab that URL. You can also grab this URL just by copy this. But here, this is a command for you to grab this URL. And once you have this URL, you're trying to test this URL by sending this prompt. As a guardian of Agentverse, what is my primary duty? Or you can send anything else. And then what you expect to do is expected behind the scene is you want this Gemma 4 model and like answering this question. And let's see what is the response. I'm just gonna copy this and paste it to the terminal. Time to verify if everything's working.
Yes. So, and now all it's doing is resetting the environmental variables because we're running that set env.she file each time just to make sure that in case you lose context, because the build process takes a long time. So throughout this lab, we're setting that set in env multiple times at the very top. So that's the reason why it takes a little bit longer for each step. But it's just important to run just in case you lose any context. And then, it's going to print out the Cloud Run URL, and then we're going to call the URL and see if we can get a response from the LLM.
Yeah, so you have this URL, and then can send a post request. We are expected to see a response look like this. But maybe you're not exactly the same response here because, AI cannot generate the same result every single time. But, let's see. This is a result. Oh, wow. Okay, here. Oh, yeah, the context. Yeah. Oh, here's the result. This is a response. As a guardian of the Agentverse, the primary duty is this safeguard because of the Agentverse representing reality. Yeah, great. So that means the Gemma 4 on Cloud Run with Ollama is working. All right, so you know that we are using Ollama, and it's really easy to get started, and it's really easy to use, and we have this model baking so that we have really fast code start. You do not have to start waiting for it to load in the model and to have the initial code start problem. However, you have some disadvantages, right? So what are some disadvantages with this Ollama use case?
Oh yeah, so since we're baking in the model into the image, as you mentioned, it leads to very fast cold starts because the fact that the image is already deployed, essentially if you want to create a new version or new instance of that machine for the service, it's really easy to spin up. In our particular use case, we're only limited to one, but if we were, it would be really easy to spin up more instances for the service. But the downside to that is because we're baking it into the container image, if you want to change the model version or the parameters of the model, let's say you want to go from 2B to a larger version of the same model to a different model, you have to rebuild the image and then redeploy. So it's a long process, and as you just saw, building these images can take some time. So as mentioned before, it's really good for development use cases. Oftentimes when you're running these models locally, you may want to use Ollama. But if you're baking it into the container image, it can be pretty inflexible when it comes to kind of rapid changes. But of course, when you're using something like Cloud Build, you can automate the changes to an extent. Yeah, that's just one thing to keep in mind.
Yeah, also another thing worth mentioning is if your production use case serves huge traffic and you want to improve the performance, that is where you should really consider using vLLM. And different from Ollama, Ollama has a model baked in, but here you want to grab the model from Hugging Face and save that to cloud storage. And then, this process is a little bit similar. We try to we have this model, the CI pipeline is kind of similar. You want to build the image, but this image, it does not contain the model. It only contains the vLLM code. And then once you save that, push that to the image repository, and then deploy them to Cloud Run. And now you can see that the container image is tiny because you only have vLLM code. And then the Gemma is going to store in the Google Cloud Storage, and then we're using Cloud Storage Views to mount the bucket as a local folder. So anything you change in the local folder will reflect it. I can explain more about Cloud Storage Views.
Oh, yeah, so Cloud Storage Views is a great way of representing cloud storage folders and paths as local paths for your machine for the Cloud Run service, and that's what makes it so efficient. So as far as any package or service that's running on the Cloud Run service is concerned, it can actually access GCS files the same way that it would access local files, temp files that are running directly on the machine. So Cloud Storage Views is essentially what mediates that connection between the cloud storage bucket and it being mounted as a local folder for access directly on the Cloud Run machine. Yeah.
So anything we change in the local folder will also reflect here, right?
Exactly, yeah. So, and what makes it really powerful is that not only could you read from that local folder that's been mounted the same way that you would read from like a GCS bucket, any files that you write to that local folder is almost as if you're writing to that GCS bucket as well for persistence down the line.
So it's bidirectional sync.
Yeah, bidirectional, yeah.
Yeah, pretty cool. And let's take into how we're going to save the model to cloud storage and how to go through all the CI pipeline and set up that cloud storage views. Let's get to step 5. All right, let's get started by first download this model from Hugging Face and then save that to cloud storage. So let's get started. And what you need to do is first you need to go to step 5. And when you're scrolling down, and you can see that we have instructions here. If you don't have a Hugging Face account, you can just create an account over here. Or if you can create an account over here. If you already have it, you can just click login. And now you're in this page and to log in. And what's next is you need to click in this link to generate a token. So now I'm at this page. I'm going to click generate a new token. So you can use Agentverse workshop token as a name or any name you want. So just copy here for the Agentverse workshop name. When it comes to the permission, you can just use the read role. So we can choose read for this use case and create a token. And now you have this token ready. I just copy this to save it. So yeah, next thing we want to do is we want to run this command so that it will save the token to Secret Manager. And first, we just copy this command, and then going back to our terminal, I will paste it. So first, we want to enable this script, and then we want to run the script. Essentially, behind the scenes, we want to save the token to Secret Manager. And do you know what is Secret Manager? Might explain to everyone what is Secret Manager.
Great question. So Secret Manager is essentially it's eponymous. It speaks for its name. It's our best practice way for managing secrets, API keys in a Google Cloud context. So if you're working in a Google Cloud environment, rather than you storing your API keys as environmental variables, or sometimes really not good practices to embed it directly into the file. What you can do with something like Secret Manager is you can call the Google Cloud Secret Manager API, or there's like Python SDK, and then you can actually pull the secret during your actual runtime into your application. So it's a way of preventing you from having to actually kind of make visible your secrets in directly in the code, or having to store it in an environmental file. That adds more data governance issues, because now you have to start managing the environmental files and make sure that they don't get pushed to your code versioning repo and stuff like that. So overall, Secret Manager is the best practice way for storing and managing your application secrets.
All right, so now if you're coming back, it's asked you to paste your Hugging Face token. So what we want to do is we just want to copy the token here and paste it over here. You don't see anything. So if you happen to paste it wrong, you can go to Secret Manager here and delete the token and redo it, or you can update the token. And once it's finished, you will see the token saved in Secret Manager in Google Cloud Console over here. All right, it says success, and we can double check by refresh it. And yeah, we have this token created, and we have this one version. And if you want to see the value, you can also see view value. Just verify this value is correct. It's a correct token. You just copy. So once it's verified, all right. So we just download the model from Hugging Face, and we have this token saved to Secret Manager. What's next is you want to save this model to cloud storage. So how to do that? First, you need to create this cloud storage bucket using this command to create a cloud storage. And next is you're making sure the permission is ready. So I'm just copy this command to prepare my cloud storage so that later on I can save my model to cloud storage. Yeah. Now I finished. So we can verify it by go to Google Cloud Storage. Install cloud storage. You can search cloud storage here, and making sure we select Agentverse. And here in the bucket, as you can see that we have 2 cloud storage ready. So this is the latest one, because we have the previous one for our dungeon deployment. And yeah, we have this Guardians storage ready, so that later on we can push, and then we can push our model here. Oh, you can see we have cloud build YAML file again. What does this file do?
Yeah, great question. So what we're doing here is essentially, we're not going to go through the cloud build process of actually specifying the model that we want to download, checking if the bucket exists. So that's step number 1. We want to make sure that we've actually created the bucket, and that's set as part of this environmental variable. That's all going to be true. 2, we actually now want to download it actually from Hugging Face. So we're specifying the model that we want to download based off the ID. We're pip installing the Hugging Face hub library. We're authenticating with the token that we downloaded and saved as part of Secret Manager. And then we're downloading the model, and we're specifying that it should save to our local directory. Again, we're using GCS Fuse here. Remember earlier on in the setup, we did the warm up for the GCS Fuse cache. We're specifying the model ID, and then ultimately just copying that model to the GCS bucket. And yeah.
Great. So let's go ahead and create this cloud build download YAML file so that we can continue. Let's continue. And first, it will create this cloud build download YAML file for us to follow.
This will take about anywhere from 2 to 3 minutes. It's a pretty quick process here.
Yeah. So here we're just creating this cloud build download file with our command. And next is let's using gcloud build command to run this cloud build download YAML file so that it will actually do all the process we wrote in the blueprint. So let's just go ahead and copy this. Yeah, so while we're waiting, we can just mapping each of the step to our diagram over here. As I mentioned earlier, that first step is making sure our model bucket exists. So this is like a pre-check. And once we want to log into Hugging Face and using the token. So basically, this is the step we want to making sure we get access to Hugging Face. And then we copy the model, download the model to GCS bucket. So this is the next step. Is we want to like, once we have the token, we download the model, and then from the GCS bucket. And once we have this, we want to make sure the secret available for this build environment. Yeah, it finished. So what we've done so far is, we have this token so that we can install this model and copy the model and save everything to the Google Cloud storage. So this is what we've done so far with this cloud build download YAML file. So this is basically the downloading processing, and we can verify everything in the bucket. I'm going to refresh the page. You can see, yay, we have Gemma 4. Everything downloaded in our cloud storage. Great. What's next is, you can also verify cloud GCS bucket with a command over here. You can just copy this with a gcloud storage ls command to recursively verify things in the gcloud bucket. There's another verify.
All the weights downloaded, the optimizers, all of that. So yeah, it's just listing out the files.
Yeah. So now we verified it. The next thing is we need to finish this pipeline. So Ayo, do you know what is when we talk about network subnet, what is the subnet and why we need to compute this network subnet here?
Yeah, great question. So private Google access is a great kind of tool and feature that you can use when you have different services communicating with each other. In our use case, what we have is our model weights being stored in cloud storage, and then we're going to have a deployed model on Cloud Run. We want to be able to pull these weights without the data having to traverse over the public internet. To kind of accomplish that, we're going to enable private Google access. So this will allow our Cloud Run service to communicate with our GCS files without actually having to pull the data over the public internet. So it's going to traverse to our private subnet. So it's a really smart way of kind of keeping data secure when you have, again, connections between different services on Google Cloud. In our use case, we have Cloud Run communicating with cloud storage to pull the model weights. So that's the benefit of that.
Yeah, so you can see we have this line over here, Cloud Run pull from cloud storage. All right, so let's just copy this and continue. All right, so we should continue once we download this model and we set as VPC. And next, we want to configure our CI pipeline. So Ayo, why we want to like create a Docker file for this vLLM and everything? Like, what are they? Why we need to do all those process here with Docker file?
Yeah, great question. So what we're doing at the very first step, since Gemma 4 just was released just last week, there's actually a version of the vLLM image that's kind of specialized for Gemma 4. So essentially, we're pulling is the Gemma 4 version of vLLM, just so it's optimized for inference with Gemma 4. And then what we now want to do is make sure that we're using a transformers library that's compatible with the newest version of Gemma 4. So all we're doing is making sure that we are setting the right version of the transformers library to a version that's compatible with Gemma 4. And then all we're doing afterwards is cleaning up any default models that were pulled and setting the environment as part of the development process. And then we're setting the entry point for the vLLM server when it's being deployed on Cloud Run, and that's it. So pretty much all we're doing, again, is we're specifying the vLLM default container image that we want to use, one that's specialized for Gemma 4. We're making sure that our transformers library is compatible from a version standpoint, and then we're just doing some cleanup afterwards, and then specifying the entry point for the Cloud Run service.
Yeah, how do we know the right transformer for the version for this Gemma 4 vLLM, or how do we change it for a different model?
Yeah, great question. So there's multiple ways you can do this. Sometimes if you just want to kind of be a little bit more general, you can just say pip install transformers -- upgrade, and that'll kind of make sure that you're installing the very latest version. Other times you can look at the documentation and see what version of the library was used for a particular model. So you take a look at the Gemma 4 documentation in vLLM, you'll notice that it's using 5.50. So it's just a good way of being consistent. Yeah.
Got it. Thank you. So let's configure it by creating this Docker file. Okay, so now we want to create this cloud build pipeline. So to create this pipeline, basically is like we want to define the blueprint for this whole process. And the first is, as always, we want to build the image with Docker. So we want to build this image. So we have this image with vLLM. And then next is you want to push this to artifact registry like this. And then what's next step is you want to deploy everything, the service, a vLLM Fuse service to Cloud Run. So while I'm deploying, I'm going to copy this. I'm going to create this cloud build YAML file. Do we have different setting here for vLLM compared to Ollama setting previously?
Great question. It's pretty similar. There are some slight differences, especially because we're taking a mounted approach with vLLM. So especially before we have the model weights in GCS, and we're mounting it on the Cloud Run machine. So there's a few extra parameters for that mounting. But beyond that, when you actually look at the machine sizing, the memory, the CPU, it's the same. And the reason why is because we're pretty much using the same exact model with the same exact amount of parameters. So the same memory constraints are the same across Ollama and vLLM. But as mentioned before, we have a few other parameters to kind of, one, address the private Google access that we enabled. So to make sure that we can kind of communicate with cloud storage over a private network. And then two, to kind of actually mount the cloud storage, a bucket as a local path. So you can kind of see there's some volume mounts that have been added as parameters. But beyond that, it's very similar.
Great. So once we have this cloud built, so this is the cloud storage Fuse that we mentioned earlier that can mount Google Cloud Storage bucket with local file. So this is like earlier we mentioned. And so yeah, we have this cloud storage Fuse explanation before, and you can check this flags over here by configure the volume for enable cloud storage Fuse. Next, we have this cloud build YAML file configured, and next is let's run this gcloud build submit file as always to follow this whole instruction so that you will actually follow this CI pipeline.
Yeah, build, push, and then deploy to Cloud Run. Yeah.
And it probably take like 20 minutes or so, right?
Yeah, 20 to 30 minutes. Yeah.
All right. Looks like it's finished. Yay. So what's next is let's take a look at this Google Cloud build history. So if you click this link, it will take a look at this whole building summary, the building process. And also, you can see the Cloud Run service page by go to Cloud Run service and making sure you pick this project. And you can see that we have Ollama that deployed from the previous one, and vLLM is this one. Again, you can see that we have this URL here. This is like the link you can connect to Gemma 4 model. And just to now we want to verify everything's working. So again, we want to send the post request with this URL link, and this is the endpoint with a check completion, and we want to ask the same question, like as a guardian of Agentverse, what is my primary duty? And we want to verify if this whole deployed version of Gemma 4 on hosted on Cloud Run, is that working or not? So let's give it a try. I copy this, so I'm gonna come into the terminal and I'm gonna paste it here. So let's take a look at what is the result. Yeah, as you can see that because the first time initial load, we have some cold start.
Yeah. So let's look. So we see the response as a guardian of the Agentverse. Your primary duty is multifaceted. It's number one. If you recall the response from Ollama before, as Annie mentioned, these models are stochastic. So you can call the same model multiple times and get a different response. But overall, very similar response to the same question as before. And overall, everything looks like it's working.
Great. All right. So just have a quick overview of what we've done so far with vLLM. So first, we download this image, we download the model from Hugging Face to Google Cloud Storage, and then we have this pipeline that we build the image of vLLM code, and then deploy the whole thing to Cloud Run, and then we set up the GCS Fuse so that it will sync to we will mount the cloud storage with the local file. And let's talk about the advantages or disadvantages of this approach. Because compared to Ollama, Ollama is very easy to start and try anything, do the local development. vLLM is a great option for production use case. And it's very flexible to update the model and you can just simply swap the file in the bucket and restart. However, it has some initial cold start because it doesn't have the model baking in as Ollama does. Anything to add, Io, for the trade-off with vLLM?
No, that's a great summary where essentially with vLLM, with the approach that we took, essentially you can use something like GSFuse to dynamically update the model weights if you need to. Macan, essentially there's a longer cold start. But one caveat with that is that's really meant for the initial invocation or initial user. If you have multiple concurrent users, 1,000 users calling the same endpoint at a time, that warm instance actually won't, obviously have that cold start for future users. So it's really meant, that cold start you tend to experience really meant for the first call to that, newly created machine. But yeah.
Yeah, so here is an overview of, so far we have Ollama and vLLM. So those are the advantages of Ollama for local development and prototyping, and also has multiple GPU support. However, if you use the production use case, like vLLM has the page attention for product efficiency and parallelism for like maximize GPU usage. So yeah, it's really good for production use case. So let's just coming back for this high level architecture we have. And for today's episode, we learned how do you host Gemma 4 model with Ollama, vLLM to Cloud Run. So this is the piece we cover for today. We cover like how do you pull model from Ollama and host it on Cloud Run, and we also know how to download the model from Agentverse and then host it with vLLM. And what's next, what's next, Io? What are we gonna cover next?
Oh yeah, great question. We're going to learn lots of things. So we're going to learn how can you serve and scale these models at a global scale using something like a load balancer. How can you secure these models and protect against things like model prompt injection, jailbreaking? How can you determine if your model is actually leaking sensitive data? The answer for that is also something like model armor. How can you use these models as the brain behind a deployed agent? We talked a little bit about LLM earlier today. We're actually going to put this in practice tomorrow and use LLM to kind of connect with our self-deployed models so we can use them as the brain behind these agents. And lastly, we're going to learn how can you actually observe the metrics being generated by these models. So, we talked about cost earlier, and how can you actually monitor that from like how many tokens are being generated by these models. You can use something like a Prometheus sidecar associated with the Cloud Run instance to actually be extracting metrics such as how many tokens are being generated, what is the GPU utilization, and so on. So we're going to be learning a lot tomorrow. I hope you guys all stay tuned.
Yeah, that's a really good summary. So by the end of this 2 episodes, you're going to learn everything about this end-to-end agentic system management. Yeah.
Yeah. So stay tuned. But until next time, I'm Io.
I'm Annie. Bye.
See you.